Okay, I was going to do this as add a little, okay, as a screencast, but I have my video camera here and I was at school still. So I will demonstrate up here. I actually drew the material on this one, and mostly for a discussion of the Titan method of material. So we got this body right here, the extra body. Yeah, I'm going to just shut the sketches off in that body. So we got a round part. We can make this out of 1x2 material. So we got to edit the material, and we actually put in, you can do relative size or fixed box. And up here, I would put in the size of the material. So I'm going to use 2-inch wide. Move me out. 2-inch wide, 1-inch tall, and I'm going to make it a little bit longer than 2. I'll make it 2. Even though this is round, it really shouldn't make a difference. And I usually make it so I have a little bit of material on the top. 10 or 20, 10 thousandths is fine. And which leaves me with 240 thousandths of extra material because the model is 750 tall. That would work fine. I always do this last one here. I labeled it. I accept the program number, label it. Now I'll even call this WCS number 1. If you use 0, it'll default to G50. Okay. Now for doing the Titan method of where do we put the XY? The easiest one is stock. Use the corner. The corner of the top. There's a probe that'll do all 3 in one shot. It'll place it over the top, cycle start, and it'll do the top, it'll do this edge, done. I saved that probing program and I had it shift because I haven't matched the Titan sheets. It's working out good so far, but some people forget the shift and we end up with the left and the front are barely cut and the top's barely cut. So this the first operation is hard to mess up. If you use the stock and get enough material, I mean, the biggest mistake we have is people aren't cutting them long enough. But if you have the bar stock in there and it's big enough to do the project, that will get you right there. Just make sure when they're looking at it. Now, for following the Titan projects, he's telling you exactly what but we have enough room in there to make that part. So we do a face mill on the top, and Titan teaches all model tops. We do model top everywhere, and the bottom cut is the top. If you're using stock box top, and I have it shifted 10 thousandths, the bottom or the top is 10 thousandths. I believe the why he teaches it that way is the G code of the top will be Z0 in the code. So there's pluses and minuses to doing it either. So we do that one there and hit OK. Do the heights on this side. The model top is 0. Part will be Z0 in the code. And everything else will be referenced to the model. There isn't much on top, not much to worry about. And then we get all the roughing stuff. So I'm just going to regenerate all these just to get them done. So we use 3D adaptive. It's actually much better than 2D. It actually does pretty much everything for you. And it's the fastest computer in the world. And this one here, we haven't choose the tool that's supposed to be in there, and I have a Actually, this one I did before I gave them all a custom sheet. So this one I have to update. Go to my library. Everything's in the cloud. Building block aluminum. I'll go get my, you can go mill, flat end mill, just to narrow down the selection. Say use 0.5 or ½ inch. And right here, these are my feed and speed settings. I could tell that older tool did not come from this library. So I told them in the TM1 machine, I'm going to update this one. We want to do adaptive 20. No, nothing more than that. It closed, but if they forget to do that, up here, I guess I didn't pick it. It went right to the tool library. I didn't pick it for this thing. Building block, ½ inch, adaptive select, and now it's got all the feeds and speeds are done. We got the stock contours, rest machining. This is the nice thing about the 3D adaptive. All the heights of model top. We do model bottom and give it just a little extra on the bottom so it goes a little bit below the bottom. And we put stock to leave on here. And the way I have it set up, this where the heck is it? Optimal load setting is based on 20% of the tool. This is kind of like an unknown area of this. Okay. And the other stuff is like same tool, and just go in and pick your feed and speed selection. So this one needs an update here. I have two tools here now. I could tell the STC one is the updated one. I'll pick contour because that's a contouring profile. There's contour right there, the feeds and speeds master machine. So anyway, we go through all this. Now let's talk about operation 2, which is in a round soft jaw. So we got soft jaws right here. Original Titan models and the ones that we made. These are, let's see if this is correct. This one here. Oh, this has the wave up to flip. Here's soft jaw. There they are right there. I'm going to close up this. If you're using, I'm going to close up NC program. This can get. Okay, so I got, this is like the whole enchilada. I got op1, and if you have this sync view with active setup, and you click right to the right of this one, it'll flip and orient to the home view of that operation. I used to go and make all these multiple views. I don't need to do that anymore because now it's synchronized. If I click to the right of op2, it's already synchronized. We added engraving. This was just an add-on. Then I can turn on my jaws. This is not the soft jaw program. This is just bringing the jaws in. I shut the body off and shut all this other stuff off. The only problem is it's trying to put in the stock material. It's on. So there's my. Well, I actually didn't cut the jaws in this one. I just did it for demonstration purposes. Let's see. Soft jaws. I don't think these are my updated ones. I have some on the shop floor. All right. This is how we get to the jaw. Well, actually, we have ones with a bored hole in here, but 3 inches to the right, 1.25 down. So if you go probe the side of this and shift it to here, our G55 X0 Y0 is the center of the part. And we got it captured by 250. We made some deeper ones for all three that could fit in there. 5N needs to sit in deeper. And we say here, the Z0 is 0.750 from the banking surface. Now, if I had Let's shut off these jaws for a second to turn the part back on. This is what I call my fake material setup. Right up here, I guess. And I do this negative 750, but you don't need to do that anymore because now it has from preceding setup, use rest machining. And when you click on this, you turn on stock visibility there. It's actually updated to reference the first side. So I used to do the fake the stock out. So that's really what you have on the second operation. When you go to simulate, on speed, get too many things open here. All right, the blue, I'm using comparison mode. The blue is extra material. The green is represents finished model, and red means you cut too deep. Used to use operation all the time, so it would change color by operation. That's like a standard. We've really gone to this comparison method. You can tell if you cut it or not. So in this one, it'd be cut the cut the top. Let me back this up. Get on a very slow computer. I'm trying to run too many things here. I run master key. Okay, my XYZ. So I set mine to cut off that stock visibility. Edit the top of the model box. Now, could I set it to the bottom? Sure, I could. I could set it right there. So when I go to set it up, I just need the center of this and the bottom. That's it. How do you find the center? This has no hole in it, and this big chunk of square material is going to be on top, so there's no way to get there. A lot of people think you can go from the corner there or down here, right? It's not accurate enough. Remember, this is raw material, and this will get you close, but not within thousandths or less than. You want to be accurate to a thousandth or less. Going to make parts for aerospace or anything like that. Just making something that looks cool, it might be close enough. I'll tell you what happens if you try to chamfer anything on the second side. A couple of thousandths is very visible. You'll see that you're not aligned to it. But if I did model box point, and the corner wouldn't make any sense on a round object. So that's why we go center. You did that. Then when I probe the bottom, I'm done. Probe the bottom. So my plan of this one here, I would just say Z0 is bottom. Done. We still had to get from the corner here, or we would bore a hole here and write that it's 2.5 this way and 1 inch up. So it's like probe the center of the hole, and then there's a lot of these soft jobs, we don't machine the ends of them. We bore the hole, probe here, and shift to the middle. So you try to pick the easiest way to do it, but at some point you gotta do a little bit of work. But if you want them not to crash into stuff, like if they probe the bottom and they forget to shift up, then it might be a crash opportunity. That's why when we bring this down, especially on the first tool, I have them stop when they're about 2 inches above there. We're going to look at the distance to go and see what it says. If it says minus like 4, it's like no way that's going to make it. Something's wrong with that setup. We'll say, oh, I forgot to shift it up. So if you want to make it more bulletproof, if we did edit, and I'd make this WCS 2, so I have 2 different setups, just in case you have to make another part, but I get them in the mode of how to make 2 operations and separate them. You can label it up here. It'll be WCS 2, which equates to G55. And if you want to use the bottom, and you set Z, you're done. So in operation 2, the other thing is you have extra material on the top. This one. And first operation is face mill. That's what we use. But you can use an end mill and like dynamic rough the top. We've done that on tiny parts before. So we use the stock has been identified and the height. So we don't use model top. I make them do everything stock top except for the where's the top, where's that finish line. So in the program, the top of the part's going to be Z positive 0.75. A lot of people that were hand G-code guys would never program it this way. They'd always program it like the top of the part is 0. These would be all positive numbers till you get to 0. If you did like the top of the material down and made this like some negative number, so that's kind of getting off the beaten path. But in your G code, that's going to be your positive number. And up here is going to be where you're starting from. And if you have the multiple depths turned on, and we do finishing step like 5,000, then plus you can control the feed rate separately. So we'll do maximum step down, multiple, or make them even step down, so they're all the same. Number of step downs. Now the chamfering also, to be aligned correctly, we can't go off the material. So the same thing here on use all our heights are going to be model. We can use model top because we've removed everything. We got model top on the top, and our chamfers, if it's got modeled chamfer, we put 0 here. This will get you a cutter compensation for adjustment, but we put tip offset, which is the down part. Plus these little tips come up. We use that as a standard setup, and we don't have to worry about clearing anything. And we always add in this engraving, so they'll put something in here, and we really don't use engrave anymore. We use trace. Trace is much simpler. Trace, you click on it, you're done. All these are model top. These will be the offset from the top. And here is axial offset. That's the depth of the part, right? Where how far the tool's going in. We always put it negative 3,000, so we want no lead in and lead out entry. So that's actually just going to engrave those. So as far as where do you put the Z, you got op 1, you got raw material corner. Using stock box point is the simplest and really bulletproof method right there. Stock corner, set it up, set all the tools off the sensor, or if you're doing top of part with manual touch off, you'd edge find the corner and set all the tools off the top of the material, you're done. Operation 2, we want to be related to the model, so if you want to pick center of model and bottom, how do you find the center? You could do it from the corner of the vice jaw, but you'd have to have the same exact vice jaws in there. That's why we pick a known location and we write it down. We got a blueprint here. It's like it's like a map, how to get to the middle. We spell it out here. This is where our XY0 is going to be. And we put it in here. Z0 is the bottom and shift up. Now you can put this as Z0 is bottom. But in some cases, you still got to, if you have a round object in your part, you can get access to it. But you try not to plan around that. I'm just trying to plan if the part's rectangular and you don't need a soft jaw, we would just lay it in there. Like this one here, rectangular part. The fastest computer here. It's a rectangular part. Our operation 2, got operation 1, which is the upper corner, and then we Technically, in industry, you want to be related to the datum, so we use the opposite corner. Not really necessary if you only got like one vise, but we're aligned to the corner. So all we do is we put a 1, 2, 3 block in there, probe this side, this side. You can't use the material because this is hanging over here. You can't probe that. It's unprobable. You know? We put in something to simulate it. But if I wanted to change it to bottom, pick the bottom corner right here. Oh, small. That would be my bottom. It's still the same face cuts. They're all relative to that area. Only I like doing it quickly with the skinny parallels down here, and the ball is bigger than the flat top. So I put a 1, 2, 3 block and probe the block, and I'd have to shift down to here. We're just shifting to here. So at some point, you got to think of shifting. That's my take on all that stuff. Okay, talk to you later.